Hello, everybody, and welcome to today's webinar presentation, Snowflake Data Apps Demo, Auto-ingest streaming data from Twitter with Snowpipe, brought to you by Snowflake. I would like to introduce you to our presenter, Daniel Myers. Daniel leads developer relations at Snowflake. He's held leadership roles in product development, engineering, product marketing, and business management from startups including Livewire Hosting and PetroCloud to Fortune 500 companies like Google, Cisco, and Fujitsu. Daniel is an inventor of 3 patents and has a bachelor's degree in computer engineering plus an MBA from the University of Texas at Dallas. This time, we're going to start the presentation with Daniel.
Hey, thanks. Like was said, my name is Daniel Myers, Developer Relations here at Snowflake. Today, I'm going to be going over a demonstration of Snowflake itself, and more specifically, how you can use Snowpipe to automatically ingest streaming data like Twitter data directly into Snowflake and visualize that data using a dashboarding tool like Tableau. Let's get started. So the first thing that we need to have a common level understanding of is Snowflake's broader platform. Now, Snowflake is more than just a database. You've probably heard the term the data cloud, and that's truly what Snowflake is today. It allows you and enables you to utilize any of your data sources, whether it's third-party web log data, IoT data, OLTP, OLAP data, any of these data sources can be ingested, streamed, and utilized onto the Snowflake platform. Now, there's 6 main workloads that we target today. That's data warehouse, data lake, data engineering, data exchange, so that's like sharing data and things like that, data applications, and data science. All of these things run across all 3 major cloud providers, GCP, AWS, and Azure. The key aspect here is that with a data cloud, you are able to connect all of these pieces together in a unified way so that all of your data consumers have just one location where they need to get that data from. So whether it's to operationalize and report on that data, ad hoc analysis by data engineers, or real-time analytics directly embedded inside your application, which today we're going to be focusing on data application workloads. And so there's a few key things to understand about the architecture behind Snowflake that makes that data cloud work. So there's 4 main layers here. As I said before, there's the cloud agnostic layer where Snowflake is able to run using the native resources of each cloud provider, GCP, AWS, or Azure. Now, the next layer up is cloud storage. This is where you are able to actually independently scale with compute the next layer up between those 2 aspects, right? With legacy databases or legacy cloud storages, you won't be able to scale that in the same manner. And so when you can scale compute and storage independently, it really enables you to have a different kind of use case. For example, you can actually have compute that's dedicated to a specific team or a specific project or even a specific application. This means that you won't have queries that are competing for resources when you're trying to, at the same time, ingest more data. And so the 4th layer on the top there is really those cloud services layer. That's where you have transactions, the security and governance aspects, all the metadata that really enables the workloads to operationalize across each other. The sharing, collaboration, and user management, things like that. Even query optimization lives within the cloud services layer. Now, it's important to know some of the common use cases that run across data apps. So for example, Customer 360. That's the idea of knowing the customers that are coming to either to your application or to your store, things like that. Internet of Things, right? Where you have sensors everywhere and we're streaming those events into Snowflake and we're able to analyze those events and do some type of action based on those events. Machine learning and data science, right? App health and security analytics. App health is an interesting one. So that's everything from the security that's going on behind the network of your application to different streaming events of clicks, for example, on a website or your mobile app. to embedded analytics, which is the idea of embedding a dashboard of some kind directly into your application that's run by Snowflake. Pretty cool. So the next really great aspect about Snowflake and for data app workloads is that you have a wide variety of different drivers based on the environment that you're developing your application in. Whether or not it's JavaScript, Node.js, .NET, Go, Java, Python, etc. There's a ever-growing ecosystem of first-party drivers that Snowflake directly develops ourselves, as well as third-party inclusions into other frameworks, right? So that's going to be really awesome to see as that continues to grow and get bigger. Now, some of the key features that are specific to data apps and how it's so useful is first and foremost semi-structured data, right? This allows you to natively query directly in SQL things like JSON or XML, Avro, and it utilizes a variant column name, right? So what this means is that you can have a single SQL statement that can get a particular element within a JSON document. So pretty cool stuff. Next is zero copy cloning. This is a really powerful feature because what this enables developers to be able to do is have essentially a logical clone of your data. This means that it's not actually cloning the data on disk, but instead you're able to have another logical clone of it. So you can have one for prod and one for dev, where it's actually looking at the same underlying bit of code, bit of storage on disk. And what this enables that to do is that there's no periodic refreshes from prod to dev. If you're trying to do some type of testing on things, literally reduces by half the amount of storage required to copy those things, right? There's only one actual storage element, so there's no actual cloning involved, zero copy. So it's a really powerful feature specifically for developers. Time travel. This is one of my favorites in that this is a lifesaver when you, for example, maybe accidentally drop a table. You can actually query the database literally, quote, as of a specific time. What this means is that it's not just for accidental deletions, but if you're looking to have versions of data, you can do that now directly within the Snowflake Data Cloud. All of this is via SQL extensions. So again, that's the key element here that you'll see a common theme within Snowflake is that everything, all actions that you do can be done in SQL. Really awesome. Adaptive caching. So what this enables you to do is have really fast access to query planning. This is done automatically for you, and there's not a whole lot that you need to do really for this. This is one of those things where it really reduces the amount of management required to run your data application on something like Snowflake. Extensibility. So external functions is one of the most powerful features on Snowflake today. This allows you to directly call things like Lambda functions or GCP cloud functions directly from a SQL query, for example. And so you can have event streaming that's happening, calling an external function, for example, to translate some text, right? So it takes some text from the database, it gives it off to this external function. The external function then returns the translated version, and you're able to save that in another table or update to the existing table, etc. This now starts to get where you have event-based things happening directly from your database, calling all of these external functions across any cloud provider. Really awesome. Snowpipe. This is one that we're going to be going over today, and this is what allows and enables you to have automatic ingestion of data as it comes in. So you just configure it once. It's all event-based. So as new data comes in, it's automatically grabbing that data, automatically loading it into Snowflake, and making it accessible to any user on Snowflake that can query it. So pretty cool stuff. So automated ETL, Internet of Things, is a really big use case here. We're going to be using this to automatically ingest those tweets today. So we'll see that here soon. And so, the other really cool thing actually about Snowpipe is that the credits used to do it can be very low because it's automatic. You don't have to have a dedicated compute resource that is just on all the time listening. Snowpipe does that for you. So the Snowflake Data Marketplace, this is another very powerful feature of Snowflake in that you have direct, instantaneous access to a lot of different data providers. So everything from COVID-19 data sets to weather data sets, you can search all the various categories on the marketplace. And what's cool about this is that you can get tailored data from these data providers. The data itself is natively shared on Snowflake, meaning that when the data is updated, you're querying it just as if it was another table on your database already. And it's all completely managed by that provider. So it's really powerful and enables you to get instantaneous access to updates as well, because those are, again, just you're querying it just as if it's another table on your database. And it's all available on the marketplace today. So the other thing is geospatial support, right? So as you're building an application, there's a lot of times where you need to have specific locations of queries, right? So somebody from Dallas, Texas might be looking for a place to eat, right? And you want to be able to search within a certain distance or intersections and things like that, or a containment within a certain field in Geospace. So you can do all of that natively on Snowflake today. Really awesome. So the key aspects here today that this demo will show you is data loading. So specifically, like I said, Snowpipe. We're going to be using Snowpipe to load Twitter data. We're going to be showing semi-structured data. So all of this data that's coming in from Twitter is all in JSON. So we're going to be loading this JSON data raw directly into Snowflake. And then we'll be using secure views to allow data analysts to query that data. Pretty cool. So the overview of kind of how this architecture takes place is I have my machine here that I'm going to be grabbing all of this Twitter data from. I have a Python application that's running in a Docker container. And this Docker container Python application is listening for new tweets from Twitter. As it's grabbing those new tweets, it's going to be saving a small file. It's going to get 100 of them at a time. And each 100 tweets, it's going to upload it to Amazon S3, where then Snowpipe is listening for S3 events. Hey, boom, a new file just was uploaded, and it starts to download that JSON, that large document file, and ingests it directly into a tweets table. And then we're going to be creating that view, that tweets BI view, and to structure this semi-structured JSON data. And we're going to be doing that within a tweets warehouse. And then I'll show you also how you can view and visualize some of this data directly in Tableau. So let's go to the demo. What we have is my Snowflake instance running. I have my storage. I'm going to be creating the warehouse. So let's run these one by one. So I use the role sysadmin. Now I'm going to create and replace the warehouse. So this is the query to do that. The next, I need to actually create the database where I'm going to be storing all of these tweets. And next, I create that stage. Now, what is the stage that you ask that I'm telling you about? That is the piece here where I am uploading the files directly into S3. The stage is what Snowflake uses for ingesting it. Now, for those of you that notice, hey, Daniel, you have your secret key here. Rest assured, by the time you see this, this key has already been deleted. And so The next piece that I have to do is create a table within my database. And you'll notice here the key element within this command query is the variant column type. And next, I create the pipe. Now, this is where it's actually going in. It's copying into the tweets table that I just created here. It is copying it from here into my table. And now what I'll do is I'll go ahead and show the pipes running. And so I've previously already ran all of this, and so you already see the name tweet pipe, database name of Twitter DB, and here's the definition of my pipe. And so with that, what I can do now is I can start to view some of this data. Now, before I do that, though, I need to start up my Docker container that's actually going to be live streaming these tweets. So what I have here is a Docker container that's running a Python application. That is, when I click this, it's looking for and searching for a very specific hashtag, COVID-19. And what I'm doing here is every one dot represents 2 tweets. And once it gathers up 100 tweets, it's going to upload this single Twitter file into that S3 bucket, and everything will get kicked off at that point. So let's go here and start viewing some of the tweets that I've already set up in here. So I set up my various context. I use my schema. Now let's go ahead and list out some of the tweet files that I've already uploaded. You'll notice that each of these S3 bucket JSON file has been uploaded. Looks like I have 20 of them, so it represents about 2,000 tweets in total. And so let's actually select one of these and view them. So you'll notice here, I can do that, click on this, and I can actually view some of the JSON data within these files, right? And so this is what it looks like. Lot of information in these in each JSON object. So let's take a look and view my pipes again. From here, I can still see my tweet pipe is running. Has been created, I should say. And let's actually look at the status of this. So you can see here that it's actually running. There's no pending files, so all 20 of those files that I showed you earlier have already been processed. That's great. So when I look at the contents of the tweets table, let's look at that. So you can see here a total count of 2,000. Awesome. Let's look at the actual contents from the tweets table itself. You can see here each tweet variant column type. I can click on that and view the JSON data again. And now what we're going to do is this is really where the magic happens, because what we want is to be able to have Tableau view and visualize this data, this JSON data. The way we're going to be doing that here is I'm going to be creating a secure view called Tweets BI, and I'm going to be selecting particular elements within that JSON object and assigning it to a column within Snowflake. And so you'll see here, I actually have even the type, so timestamp, string, int, there's even a Boolean in here. I can assign each of these a column, and that way Tableau can query it just like any other SQL database and be able to visualize that data. And so when I do that, I can run and see how many rows there are inside of that view. And now I can actually view the structured format of that JSON data. So you can see here I have some previous queries that I've done. So Lakers, scroll down a little bit, and I can see some more different types of data. And from here I can see, you know, everything from user description, you screen name, how many times it's favorited, user profile links, etc. So pretty cool stuff. And what I want to be able to do now is if I go to my Tableau dashboard, you can see some of these tweets running in this dashboard here. So I can actually see Twitter for Android is the #1 client for Twitter. I can also see just a raw list of some of the tweets coming out. What's interesting to me is that a lot of the tweets that are actually created are simply retweets, right? So it's literally Twitter is in some regard a literal echo chamber. So that's interesting. And so from here, right? So I've shown you now how to create the stage for how to create the stage for importing these tweets. I've shown you how to pinpoint and view the unstructured, semi-structured JSON data, how to query that data, and how to create a view of that semi-structured data for Tableau. And so let's go back. Awesome. So how can we today download the source code of this demo? Well, it's good. It's available right now on Snowflake Labs on GitHub. So you can do it, view it right here on this link there. You will need a Snowflake account to run this demo. So you can get that account today at trial.snowflake.com for free. You also will need a Twitter developer account to get those live tweets coming in. So you can sign up for a Twitter developer account at developer.twitter.com as well. Now, what's really exciting about a lot of this is that we have so many companies developing data applications with Snowflake today. Everything, from Instacart, Okta, SendGrid, you name it, and they're working with Snowflake. So it's really, really interesting to see, really exciting. And I think it really shows the power that Snowflake can provide a lot of these data applications. So, we even have a broader look here from data integration, ML data science, security governance, all of these different types of ecosystem partners that you can leverage when working with your data application on top of Snowflake. So really powerful and ever-growing ecosystem of partners and applications. So what's next from here, right? Well, you can learn more at developers.snowflake.com. There you'll see a whole lot of different resources that you can download, that you can read up on. You also, like I said, you can get a free Snowflake trial at trial.snowflake.com. And be sure and join your local Snowflake user group, right? You can meet other Snowflake builders, developers, and even other Snowflake experts, right? You'll even get to check out some of our data heroes, which are it's a specific program here at Snowflake where you can actually gather points based on all the various things that you're doing, and it's a really awesome community of people on community.snowflake.com. And last is check out this demo on github.com/Snowflake Labs. You'll also find on there a whole lot of other demonstrations and examples that you can download and play with on your own environment. So with that, I want to say thank you. My name is Daniel Myers, Developer Relations here at Snowflake. So questions are live now. Let's go.
Awesome. Thank you so much for that, Daniel. And like he said, we're going to enter the Q&A portion of the webinar. And Daniel, we have our first question here for you today. And that question is, where can I download the source code for this demo?
Yeah, great question. So all the source code for this demo that you saw today, so being able to ingest the Twitter data, visualize it in Tableau, everything, is all inside of our Snowflake Labs GitHub organization. So if you just Google search Snowflake Labs, it'll be the first result there. And we actually have the source code for many demos, not just this one, but you can also get one for creating a recommendation engine on Snowflake, a movie recommendation engine, things like that. So check out Snowflake Labs. You'll be able to get all the source code there.
Awesome. Thank you so much. Another question someone from the audience is wondering is what event notification was used to trigger the pipe?
Yeah, that's a great question. So for S3, there's actually a couple ways that you can do that. So you can use both the native S3 events that come in, but you can also use AWS's queuing system as well. And so that's both of those are available. And on top of that is that Snowpipe actually has its own REST API. So let's say you have some custom built queuing system that you want to use to trigger a new ingestion. We provide a REST API that you can hook into from any platform anywhere to trigger those ingestions.
Good to know. Another question is, what is the difference between ETL and ELT, and what is the best practice?
Yeah, I love that question. So the difference between ETL and ELT is basically where you're doing the transformation of the data. What's cool in Snowflake, as part of this demo that I showed, was that I was essentially doing transformations directly in Snowflake. So I was first extracting the data from Twitter, right? And then I was directly loading the data, the raw JSON data into Snowflake. So instead of having to do some transformation before ingestion, I can ingest it first and then do my transformations. And so that's the difference between ETL and ELT, is where you're doing the transformations. And with Snowflake, being that it supports both structured, semi-structured, and even now unstructured raw binary data, all in hybrid tables. So you can have a structured a column that's type text or date, time, or anything like that in the same exact table as your JSON or semi-structured data. And so what I've found to be best practice is to start doing the transformation in Snowflake, because Snowflake at that point becomes your processing engine. You get all the parallelization that comes with SQL, right? And so all the optimizations and query planning that Snowflake does under the hood, you get to automatically out of the box take advantage of. So definitely, I would say the best practice and industry is moving to a transformation after loading.
That's super helpful. Thank you. We've got another audience question here. And this person says that they are new to Snowflake, but they have a little bit of experience in big data technology. And they're wondering how Snowflake is different from Hadoop in terms of storage and processing.
Yeah, so how is it different from Hadoop in storage and processing? That's a good question. I mean, I would go back to kind of one of the key differentiators as to the architecture that Snowflake provides, right? So first and foremost is the fact that Snowflake is truly cloud native. What do I mean by that? I mean, Snowflake will use automatically the cloud provider's native paradigm and resources for running your workloads, right? So AWS has EC2 instances. GCP uses something similar, VMs, right? And the same thing with the actual data storage itself, right? So AWS has S3, GCP has cloud storage, and Azure has blob storage. All functionally very similar, right? The APIs are slightly different, and some of them have slightly different capabilities. But the beauty is that Snowflake uses all three of them, right? And that is ultimately that is that cloud agnostic layer for Snowflake. And then you go one layer up, and there are two layers up. The next two layers is the separation of storage and compute, and the fact that when you scale up Snowflake, you don't have to bring anything down. You don't have to change your operational, your business operations to fit some technical limitation of the platform. you can actually have separation of compute with other compute with Snowflake. What do I mean by that? I mean that it's not just one massive blob of compute that all queries are competing for resources in, right? So you can actually have, what we call a warehouse is basically an EC2 cluster. You can think of it very similar, right? And so you can separate out compute with other compute. So different teams within the same Snowflake instance can have its own dedicated compute resources for their own queries. You can even have like an entire workload that's just, say it's your some application workload that has its own dedicated compute resources or warehouse for its own use. And then anytime that your finance department or some other department wants to leverage that same underlying data and do its own queries, you can spin up a new warehouse, no changes needed for everything else, and it works just fine. So I would say just the fact that Snowflake is cloud native, bringing it back to the question, the fact that Snowflake is cloud native is the biggest difference with Hadoop versus in Snowflake and things like that.
That was very insightful. Thank you. We've got, it looks like, a few more questions here from the audience. One of those being, when should you use REST API over AWS SNS or SQS?
Yeah, great question. So I would say when you have something that, for example, one key difference is that if you're using, like AWS's kind of native, event system or simple query service, it will trigger on each new object upload, right? So like on object creation. Let's say, for example, though, you wanted it to ingest several at the same time or something like that, right? Where you want to have a little bit finer grain control, or you want to change the way the ingestion periods, right? You have that level of control with the REST API. If it doesn't matter to you or doesn't have any impact on your application, like in terms of when exactly, like, hey, I just want it the moment any object is uploaded, I want it to automatically ingest, no questions asked. Definitely just, you don't need to use the REST API. But if you want, some type of custom control over when to ingest data, the REST API is there for you to use.
Good to know. Our next question is, what's the best recommended data visualization tool to work in a Snowflake data source?
Yeah, that's a great question. So Snowflake actually provides its own. We have a thing called Snowsight. That is the native dashboarding tool that Snowflake has today, is Snowsight. So definitely check that out. If you're looking for, say your organization is already, using another platform, Tableau is great, right? Tableau is great. That's what I showed here in this demo, is that actually running in Tableau. But that's really, at the end of the day, the beauty of Snowflake is that, the ecosystem of dashboarding tools and visualization tools is at your fingertips. So, I mean, let's say you wanted to even build something custom in React or D3, right? Some JavaScript libraries, and completely customize your visualization experience. At 100%, you can do that. And so yeah, I would definitely, the first one to check out is the one that just comes with Snowflake, Snowsight, and just move up from there.
Great, good to know that there is a built-in data visualization tool with Snowflake itself. All right, Daniel, we've got 3 more questions for you. One of those being, how does Snowpipe handle errors when there is an error?
Yes, great question. So you can, that is a configurable option of Snowpipe. So you can make it basically, ignore and drop things, or stop when it happens, and create some alerting mechanism, for example. So I would definitely check the docs because there's a lot of different things that you can configure, including the error behavior is one of those things that you can configure.
Good to know. Okay, our second and last question for you is, does Snowpipe support other cloud providers?
Snowpipe support other cloud? Yes. So Snowpipe you can use, in this demo I showed it working with S3, but 100% works, with, Snowflake itself is cross cloud provider. So Snowpipe also cross cloud provider. So one of the features of Snowflake. So any blob or object storage is the key there, where you can ingest automatically event-based data as it comes. You can configure your stage. So if you're looking to kind of learn more how to do this, definitely check out, there's a whole guide actually on this that we have on guides.snowflake.com, getting started with Snowpipe. Very, very popular. There's actually a whole guide if you want to walk through this demo that I gave today, in addition to the source code of the demo that's on GitHub, you can also check out a complete step-by-step walkthrough so that you can actually build the demo that I just gave on guides.snowflake.com. So definitely check that out because it'll have a whole lot of really good information for you.
That sounds like a great resource to utilize. And our last question for you today, Daniel, is an attendee is wondering, how should they split up their data for Snowpipe?
Yeah, great question. So really, Snowpipe will work with any file size. It doesn't matter if it's a big file size or super, super small. With that said, generally speaking, what you want to optimize for Snowpipe is basically the parallelization of the files ingested, right? So what we've seen is that generally speaking, you want to keep files around 100 megabytes, because what that does is it optimizes the essentially file transfer speed, right? So there's amount of transfer speed over the wire for files, and then there's new TCP connections being made for each new file that's being transferred. And so what you're balancing is the new connection spin up phase and the wire transfer rate. And so generally speaking, we see that files around 100 megabytes is kind of the sweet spot for the file size being ingested.
Nice, very informative. And I believe we are through all of our audience questions today. So with that, DZone would like to thank Daniel for a phenomenal presentation. DZone would also like to thank Snowflake for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career. Have a great day.